welcome everybody to the webinar about SONATA Release 5.0. What we are going to do during this hour is to use features and how to use it from a practical viewpoint. So, however, at the beginning, I'm Josep Martrat. I'm the project coordinator of the Tango project. So what I'm going to do is to set the scene about what are the motivation and why the results and the SONATA results are so important and how it frames in the 5G context. Okay, because we know that the out of 5G is not far from being a reality. We have the vendors, we have the NMBOs that have the release and the deployment on the 5G equipment, and also NMBOs are the operators are commercializing these 5G networks already in the market. We know that the 5G is not only the evolution of the mobile broadband network, I mean the new radio, and it brings a unique service capability. What does it mean? So it means that beyond the radio, we have about this set of services that complement and are fundamental pillars of the deployment of the 5G. And despite the marketing messages that exist today, as you see in the slide, the scenarios of 5G will take some time to roll out. And the reason is that, let's say that 4G has still a lot of performance. And if you look the level of penetration in terms of mobile subscribers worldwide, 4G is still the lead. And the coming years, 5G is little by little being introduced. So it will take, despite. We know that 5G is coming with several advantages, and the promise to provide more ubiquitous coverage, high data availability, and to achieve this type of promises, it is necessary to densify and provide a higher capillarity, if you wish, of the access points and the whole 5G system in order to increase the capacity. And this requires to deploy and manage a large number of network elements. So it is true that when you go for the, let's say, the triangle traditional 5G cases, the cases that are being deployed are related to. So I think, okay, it was a background noise. So if you look at the triangle of 5G cases, the first case that is being exploited, let's say, is the more capacity, the enhanced mobile broadband. This is obvious for media cases and coverage, like fixed wireless access and US and so on. But from our viewpoint, the more, let's say, genuine use cases will take some time to come, related to more machine type communication, ultra reliable and low latency and real time cases. So these are scenarios that, and you say, why you are going in that direction? Because these are scenarios that are very important for the operators. As I said, are pushing the service to the edge of the network and will require some virtualization techniques and managing through networks with this complexity. So we all know that SDN and FV are some, let's say, transformational technologies that are pushing the evolution of the 5G and the telecom market, let's say. However, when you look at the status of the software networks and you ask, what are your concerns and what is the status of adoption in your networks? Not because you have done already some proof of concepts, but what is the real status? All analysts, when the operator said question and the reply says things like, think of problems with the skills to integrate both SDN and FV together. Or we have problem interoperability if you go to a multi-vendor environment. you ask the operators, but is your BSS, your business support system, able to handle virtualized service? Are saying, not yet. We are having problems, but not yet. So there is a path to go, because the value proposition of SDN and FV was originally, let's reduce the capex, let's reduce the operational and have these savings there. The truth is that in terms of programmability, in terms of deployment, and in terms of has changed to do new things, and new things are these new scenario of 5G, these genuine cases I was mentioning. If you ask directly to the the operators, what are the challenges? Do you see the problems for the adoption of NFV-SDN? They told us combining and going for across domain cases. We have lack of simple tools to do the design of services, problems to define the service descriptors, to do the onboarding where there are complex services to do. We need to introduce more and more SLAs to guarantee the service assurance, etc., etc., etc. So looking at this, 5G Tango has produced a set of results that are replying most of this set of expressing, and this is a pretty new result that we have available. I cannot forget the fact that if you look at the telecom industry, let's say that the open source during the last 3-4 years, we have seen how many open source initiatives has arisen and has been produced in the area of, for instance, NFV. We have ONAP, we have OSM, we have ONOS, we have SONATA, that is one of the results that we are presenting now, that the last release in September this year. So these open source projects are gaining more and more acceptance in the telecom industry because of the certain vendor locking. And this acceptance is because the orchestrators by themselves are maturing. So we have, let's say, past the hype era in which it seems that this is going to be completely change the telecom industry, but now we are facing that when you go for a normal release of these technologies in the operators, they see this more as an evolution. Operational is the difficult part. So when I said before, okay, let's look at what are new scenarios. These SDN and FV are so important with such a large number of network elements to manage. The trends indicate clearly that services are moving to the edge, and the scalability there in order to provide new cases, more real time, more low latency, and so on. It's a trend. The problems that I all mentioned, it is necessary to improve how you validate, how you test, how you qualify a service in these NFV environments. The problems with dealing with a multi-vendor, because this is creating an ecosystem of actors that are producing VNFs, that are producing services that are orchestrated. And so this is a multi-vendor situation, and you cannot be locked in by a concrete vendor. And trend to reduce costs through the automation of the operational part of this. These are trends that are here to stay. And so just to, if you think about, okay, I'm going to deploy a service, because the rest of the presentations is, okay, let's see the architecture, let's see the building blocks, how we deploy the service. Any service, let's say that has 3 main pillars or 3 main phases. At the beginning, you need to do the programmability of the service, and 5G Tango has produced a set of tools to support the developer. And this is normally done in a local environment, in the laptop, the developer doing this or providing this new service and needs to test and do some test and emulate and these test that everything is working properly. This is a second phase in which the service needs to be validated, need to be verified, and a battery of tests that in order to understand that the service is working properly, let's say in a qualification environment, that is like a mirror of the production environment. And here we have an important result about the BNB platform that we are proposing. And in the end, you go for the operational part. When you go for this, you introduce the SLAs, you introduce the policies, and you are working in a production environment. And here you need the service platform with the manual at the core and so on. And this creates a much more dynamic environment with the DevOps approach between the developers and vendors, the qualification services and the operational part all together in a DevOps cycle. So just to recap, what are the key messages on these part of trends within the 5G and SDN and NFV as pillars of the evolution of this? So it is not possible to, I'm sorry, now here, okay. If you look at messages and this initial part, introduction is very, very important, the orchestration part, and 5G Tango is producing an orchestrator here with all the mechanisms to do the automation to reduce cost. You will see that also we are ready to deploy cloud native services, deploy this in Kubernetes, deploy this at the edge and so on, and reach really what I said, scenarios that enable the 5G, enabled by 5G in different vertical industries. So this is the context in which the project lives, and this is where it brings value. So now we are going to see more the features and the architecture, the building blocks of the results that we have in the release 5.0. So it's the second part by Jose, right?
Yes, hello. I don't have the presentation here. Can you, Josep, can you put it live again?
Sure.
Thank you. Okay, so I'm José Bonet. I'm coordinating, technically coordinating 5G Tango, and I work for Altis Labs in Portugal. Okay, so in the next slide, please. Okay, so Josep has already presented this scenario. Here is a very simplified look at it again. So we have on the left side service developers or service authors, if we want, that provide services to service providers or deliver services to service providers that explore them and sell them to service consumers. Okay, next slide, please. Of course, with the 5G environment, a 5G ecosystem, what is envisaged is not only the multiple service consumers we already have, but service developers are expected to explode in numbers by the lowering barriers that 5G provides. So in this case, the service provider faces different problems than before, namely the ones about not only about scaling and protecting the network, but most of all, next slide, please, security issues about these multiple service developers that now have to or have the right or have the ability to provide services directly into the infrastructure of the service provider. Next slide, please. So the 5G Tango addresses these issues by providing, like it was said already by Josep, a service development kit holding several tools that we will address both here in this presentation on the next slide and in the next presentation. A verification and validation platform, which is nearer the environment that the service will have to run in, and a manual or a service platform that is able to deploy services either in a more traditional, let's say, virtual infrastructure environment like OpenStack, and also in Kubernetes. Open source Mano is there because the VNV can also test services in OSM already, not only on our service platform. Okay, next slide, please. So the whole architecture, the whole 5G Tango architecture is this one. On the left side is the service development kit that I have mentioned before. So in this case, we have a set of tools mainly or of which I would emphasize two of them. A validation and testing tool, which allows us to very quickly, and as we develop, write the service descriptor and the functions descriptors with their more or less complex network connections that will then be implemented by the SDN part of the infrastructure, we are able to get feedback in a very short time, allowing us to dramatically increase productivity. We also provide an emulator, which is another, let's say, a wider feedback loop enabler, on top of which we can deploy our service and test our service. Just one more tool, as I said, later on we will have another presentation on this, but one more tool is the specific service and specific function managers. Not all services and all network functions are alike, so we may deploy services and functions in our infrastructure with very specific, for example, networks or very specific changes, very specific to that function or to that service. That's what those components are for. So after having a reasonable amount of feedback, the service developer may deploy the service or pass the service that he or she has developed into the VNV platform. In the VNV platform, I would highlight also components. A planner. A planner basically receives the description of the service or function and checks in the database, in the test specifications catalog, which tests match that service. We do this by usage of a tagging system. If we tag the service in the same way as we tag the tests, these will match and a test will be planned to run against the service. Then there is these plans are passed to a component we call the curator. The curator basically prepares all the environments that are needed. For instance, instantiating the service in the platform that we want it to run, which could be, again, either Sonata or OSM. And then this is passed to the executor. The executor does what it does, executes the test, collects the results, and returns to the curator for the results, either a pass or fail of the tests. This is a very flexible and scalable system of implementing this. We have also other supporting tools within the VNV, like the platform adapter, which allows us to add new kinds of platforms and absorb the changes in this platform adapter. Analytics engine, which allows us to observe with greater detail the results of each one of the tests run. Decision support, which allows us to recommend some tests for this specific service or things like that. So the VNV is a very relevant block in our project and is one of the assets that we provide. And finally, the final block is the service platform. In the service platform, services are deployed, as I said before, in VIMs that may be Kubernetes-based or OpenStack-based, in multiple VIMs, which means that we might, or data centers, which means that we might have to connect different VIMs with a WIM, a wide area network infrastructure manager, and we have very experiences and experiments in that, in one of the pilots, for instance. And we also have the ability to define slices. Sorry. We also have the ability to define slices, policies to protect the infrastructure, define SLAs and licenses that address the needs of each customer, and so on and so forth. So next slide, please. Okay, so very briefly, the SDK and the emulator, we have the facility, the ability to automate many of the issues that enter into service descriptor. We adopted a principle that is now common in software development, which is packaging all the assets that comprise the service. We do, as I said, we described very briefly, an initial validation, both through an emulation and through a validation component. We connect, deploy that into the VNV for it to process. This basically is the first feedback loop of a DevOps approach that we will have more on. Next, please. So in the VNV, the main features are the definition of test plans, which is how we, let's say, describe the test to be able to validate the service and the qualities of the service, the features, and verify that it does what it needs to do. This addresses the worries of the service providers and telecom operators about the security I've mentioned before. This is the way the service providers can enter the cycle and test the service about specific aspects of it, like security, not only. Then we can run as many tests as we can, as many times as we can, reporting results in a manageable and graphical way. We provide support both for SONATA and OSM. The flexibility is mainly achieved through a mechanism of probes that the developer of the test provides. So probes are pieces of code that are run isolated with all the security issues taken care of in order to test the service and return the results. And we also provide a comprehensive result analysis by way of tools that easily integrate with tools like R and things like that. Next, please. Okay, in the service platform, we provide some features like resilience, because we are able to deploy the service platform in Kubernetes infrastructure and thus taking advantage of all the features that Kubernetes gives us into balancing load and scaling and so on and so forth. We provide cloud native support. Kubernetes is a Vim. It's ready for the Mac, as Josep mentioned. Nowadays, service providers look for this very, very, very heavily, because this is how we will be able to provide performance and features like that in the new coming services. Monitoring is always present in terms of monitoring both the services we deploy and the platform itself. As I already said, yes, we have a module of SLAs that connect with the business needs, with the more business needs of the service operator in terms of guaranteeing a given customer some characteristics of the service provided. We also have a slicing module providing easy to define network slices with several services in the slice connected to connecting multiple services in the same slice with guarantees, with SLAs applied, with policies applied, and so on. And also we provide a very flexible and easy to deploy service platform. It's all automated. We may even have services that are both more cloud native with a part of it deployed in the Kubernetes infrastructure and another part in OpenStack infrastructure. So we think we have a very flexible and performant solution here. Next, please. So we are, as I said, open source. All the code, all these features and assets are available as open source in these repositories, GitHub repositories. We have adopted a philosophy of microservices design. So therefore, this high level of or high number of repositories, but we There are also documentation extensively provided. There is one of the repositories is tng-doc, which provides all the documentation that helps deploying and contributing and developing, etc. So next, please. Okay, so as a highlight and key takeaway features, we have web user interfaces for all the three assets that make management and let's say analysis of what is going on much easier. We provide also a command line interface for automation and advanced usage. The VNV, as I said, can both deploy services in a SONATA service platform or in OSM. We provide also network services, or provide network services on top of Kubernetes. We are able to use a very important, relevant WIM, kind of WIM, which is TAPI on top of optical networks. We had this need directly from one of the pilots, the communications pilot. We also support the full definition of the life cycle of a slice, as I said, the ability to define policies to protect the infrastructure, and the ability to define SLAs and licenses to govern the relationship or help govern the relationship with end users and customers. And I think that's it. Thank you.
Okay. Then now we jump to more the practical situation and usage of the different building blocks. So, Ricard, can you take the control and share your screen, or Manuel?
Hi, first of all, I'm not sure if I am allowed to present.
Do you have the control?
Yes, you will be allowed to present, Manuel. Just a second.
Okay, give me a second. I think I have it here.
Okay.
So do you see my slides?
Yes. But we see it, okay, if you go do it full screen, that's perfect.
And you see it full screen? Yeah, okay, great. So hello, everybody. Yeah, my name is Manuel Poister. I'm from Paderborn University, and I'm going to tell you a bit more about this SDK part Jose already introduced. So first of all, the important point during this small presentation is that we now really take the perspective of the network function or network service developer, so not of the operator. And I try to guide you through our tools by giving you a small example how to build a network service, how to package it, test it, and finally deploy it to the VNV or a service platform. As already mentioned, we decided to split up our service development kit in multiple small tools, following kind of the Unix idea to have specific tools for exactly one specific task. Many of those tools are delivered as command line tools, which has a great benefit that you can automate almost everything. So those tools perfectly integrate into continuous integration and delivery platforms. For example, we use our packaging tool within our Jenkins to automatically package all the network service packages we need for our pilots. And that's a great advantage. So a user can always pick exactly the tools he or she needs and does not need to bother about the other tools. Let's have a look at a simple, very simple network service, which we are going to use as an example here. So we have here a network service, which consists of two VNFs, for example, a proxy VNF and a script VNF. And this network service is going to be developed. So what we assume here that the network service developer usually first builds the virtual machine images or the container images, which contain the actual software for the VNFs. And once this is ready, we can start basically with using the 5G Tango tools to create the required descriptors to be able to onboard and deploy such a service on a service platform. To do so, we have our first tool, which is called TNG Workspace, and this is basically a workspace management tool. It's similar to Git, which allows you to manage your local workspace. to create files, add files to your project, remove files to your project, and to all this kind of management. Again, this is done on the command line because we noticed that developers really like to use it as a command line tool, for example, as they usually do with a Git or any other code version control system. On top of that, we also are able to generate initial descriptors with this tool. So we can generate kind of a template for a network service descriptor and a virtualized network function descriptor from that tool. So you get a starting point, because that's one of the problem most of the developers face if they are new to a platform like 5G Tango. They need some examples for a descriptor, so they have something to start from, and this tool generates something like that for you. And on top of this command line interface, this is even possible using a easy to use web interface. So to even lower the barrier of going with these tools even more, we provide this web interface, which is quite easy to use. Once you have your basic descriptors available, you can control this project with the Tango project tool and add additional files to it. For example, you want to add license files, or for example, additional artifacts, maybe even a logo, which is later on shown in some catalog, to your project, and then have all this inside this project structure ready for packaging. The important point here is that this entire workflow and this entire project structure with the index files and manifest files is completely compatible to version control systems like Git. So you can versionize basically the entire 5G Tango project you have, push it to Git, share it with other developers, or pull it from there. This basically ensures that projects can be open source, or can be shared within a company with a private project management or version control system. So assuming we have now created our descriptors, have described everything we want to deploy, we have our images ready, we now go to the stage that we want to validate what we have done, and we want to ensure that things can be deployed on the target platform. And for that, we provide one of our most important tools, the so-called validation tool. And this validation tool provides you with simple syntax validation, as well as semantic and syntactical validation of the descriptors involved, no matter if it's a network service descriptor or a VNF descriptor. So for example, here we might find things like typos in the descriptors. We might find things like broken references to other artifacts in our project, or we might find broken network configurations within our network forwarding plane, which should be designed by our network service. All this can be executed on the developer laptop. It runs within a couple of seconds and directly points you to those descriptors where the tool detected the error or the problem for you. And we noticed that this really comes handy, because otherwise you would need to write your descriptors, deploy it to production or to your test infrastructure, and then during deployment you notice, oh, there is a bug, and yeah, that is a much longer cycle than just running this tool here and looking at the output to fix your problems. The tool has a graphical overview. This comes especially handy if you have very complex network services with many virtualized network functions, because if you have those things, you want to design the different networks between the network functions, such a graphical view on the interconnection becomes quite handy and lets you easily find out if something is going wrong in your development. So once we have everything validated and we are sure that our descriptors are correct, we use our packaging tool to transform our local project into a single file, the so-called 5G Tango package, which is a package format which is aligned to the actual standards of ETSI, more specifically aligned to solution 004, and is then a package that can be uploaded to either 5G Tango's service platform or 5G Tango's validation and verification platform for further online testing. We designed the packager in an extensible way, so you can even provide additional packaging plugins. We provide, for example, not only a plugin to create 5G Tango packages, but also a plugin to provide native open source Mano packages. The great thing about this is that with this, our SDK becomes basically platform agnostic, so we can create packages for different target platforms, not only tying our SDK to our own tools, but also being open to other service platforms. that basically closes the part in which we develop our service. Our service would now be ready to be onboarded. Let's assume we want to onboard it to a VNV platform now. So the next question would be, okay, how would we develop tests that can be executed in those test platforms against our created service? And for that, we have an additional kind of descriptors, which we call the test descriptors, which are turned in test packages. And those are very Tango specific because they are used by our VNV platform to actually execute real tests against our services. I don't want to go into too much detail here because I think in the other presentations we will hear much more about it. The key point here is that all the tests can be described again as descriptor files, which are YAML based. And they usually use a concept of probes, so kind of test containers which stimulate your service. You can either use generic probes, which for example offer things like ping or iperf or any other well-known testing tool, or you can create your own probes and basically link it from those descriptors, which basically allows you to deploy your probe, which is given as a Docker container inside this validation platform. Once you upload everything to the validation platform, things are matched, as Jose already mentioned, using testing text against the services which should be tested, and then these tests are executed. And finally, you also specify in those descriptors, okay, if a test was executed, how does the VNV platform know if the test was a success or not? This can be done by this conditional language we have here in the descriptors, where you define basically conditions which say, okay, pass, for example, the output file of ping. If there is 100% packet loss, we assume the test to be passed or not passed. And with this, you have kind of a very generic approach to write all kinds of tests for your use in the validation platform of 5G Tango. So to conclude the SDK part, the 5G Tango SDK is a simple collection of tools which is very user-friendly and can be used in different kinds of ways. It can be used for the 5G Tango service platform, the 5G Tango VNV, but also for third-party service platforms like open source Mano. It allows you to use a very powerful validation tool, which usually helps you to find most of your descriptor problems locally before trying to upload them. And it gives you this automated packaging, which can easily be integrated into CI tools like Jenkins or Travis or whatever you want to use for it. And this is really a nice thing because this gives you kind of the end-to-end workflow, which is fully integrated from the scripter writing to the testing in the VNV platform end-to-end. And with this, I want to conclude the part on the SDK. Thank you very much.
Thank you very much, Manuel. Now I will follow up with the next part. You should see my screen now. Seeing it properly. Do you hear me correctly? I don't hear anything. Yes, okay, and you're seeing my screen properly. Okay, so my name is Ricard Vilalta from CATC. Now I will first explain you the installation and operations that you can do on the SONATA service platform. After the SDK, we need to upload this in the service platform, as Manuel has mentioned before. And later on, I will show you how to use, how to install and how to use the verification and validation platform. We think that this is the more proper order to understand because we first need to install service platform as the BNB needs to run on top of service platform. So that let's start with the service platform. This is the internal architecture of the service platform. Jose has told you about before a lot of the main characteristics. I will not go into details of them, but just for reference, all the tutorial that I will give now can be followed in this website. It is all well documented, and also there are places where you can find you can send us questions in case that you need them during the installation or operations of all the different SONATA tools. So First, we need to start with installing the beams before installing the service platform. We need to have some OpenStack or Kubernetes installations on our systems. For SONATA, we recommend to use this OpenStack installation. We are using the RDO distribution, and we have a complete installation process, very detailed in the following website. So, in case you don't have any OpenStack installation available, this is a proper way to obtain one in a very simple way. For Kubernetes installation, we also have written an installation guide for micro U8. So you can install Kubernetes on your laptop. So in order to test the service platform and the ability of the service platform to deploy CNF. So if you, in case that you are interested in having these CNFs, you are more than welcome to install Kubernetes using this guide. Then if we focus on the service platform installation, then we have two different steps. The first step is common for installing the service platform and the BNB. So we need to prepare the system to be able to have this. We recommend to use two different machines for the installation of the service platform and the BNB, although they can run together the same machine. The first step is common. As I said, we have a common installation guide, which is pointed here. You have it's basically to prepare the system to install everything. So we need to install Ansible. We need to install Dockers, so we will be using Ansible installation scripts, and we need the Docker system available on our system because the service platform runs with each component running as a container. So we need we need Docker. We also need some extra dependencies which are explained in the common installation. We also need to install Git and Git and to clone then the TNG DevOps repository. So TNG DevOps repository will be the repository that we'll be using for running these Ansible scripts. So first clone the repository and then check out the version 5.0. So you are not checking out the dev branch. Make sure of that. Finally, we need to create a Docker network for Tango, so all the containers connect to that network later on. So that's all the common requirements for the service platform and the BNB. To keep installing the service platform, you have all the commands on this website. I mean, this website is pretty simple, and if you have any trouble installing the service platform, the BNB or the SDK, later on I will refer to all how you can ask questions, but we are open to help you on that. And so first we need to run the Ansible scripts that automate this installation. Please make sure that you are in the TNG DevOps folder, so that we have created and cloned in the previous steps. And then we can also customize installation while for starting. We typically use localhost, but we could also trigger these Ansible scripts in other hosts. So this can be also configured in this file, but localhost for starting is useful. So once these Ansible scripts are completely run and installation succeeds, we can check the availability of this service platform on the portal. So you can go to HTTP localhost and the service platform should be available. And also you could use the standard login password, which is admin and Tango, or you can create your own account. So we have now installed the service platform, and now we want to run some services on top of it. let's have the prerequisites for that. First, we want to upload typically all the VMs we need to upload all the VMs that will be used in our OpenStack environment. For all the tutorial, we have created a serious, we are pointing to a serious VM. All the different network service descriptors and VNF descriptors point to this serious VM. So that's so then you will need also to deploy monitoring profs. Then we will need to configure the VIM to the service platform. So, for example, if we need to add an OpenStack VIM, you will see that we need to provide the endpoints, the username, password, tenant, domain, and so on. For the different external network IDs or router IDs which are more complex, we also provide in our guide how to obtain these values from OpenStack. So everything is available. Then we need after that to onboard our packages that we have created before using the tooling that Manuel has presented, and we provide an example package using which is consistent during the whole quick guide, so that you can try these serious virtual machines and network service and so on. So you can directly download it from this website. And once we have uploaded this, we need to open the 5G Tango portal. You type the IP or localhost as we have seen. Then we can go to the network services, and you see that the network services are listed, and then they can be activated. If you want to activate a network service, you need to push on the green button to run this network service and to create an instance. Some parameters will be requested for creating this instance. So that's the green button is here. Then a new window will ask you for the ingress and egress networks. And if you don't write any, then you can also select the SLAs and so on. But for this guide, this is only a simple behavior. We just click on instantiate, and the service will appear will instantiate immediately. Of course, if the service is a complex network service with multiple VNF that need to be deployed in the OpenStack, it might take a couple of minutes to instantiate the complete service. So to check the service once launched, you can see the status of the instantiation operation here. So you see that the status is instantiating, and it is a request still. Finally, when the service is completely instantiated, you will see that it appears in the network service instances, and the status will be the normal operation. You can stop the service using this stop button, red button on the right. So this is how you can deploy network services on top of Sonata. Simple way, you can follow up the complete example. Now we'll go through the validation and verification platform installation and operations. And the presentation will also be given by myself, Ricardo Vilalta from CTDC. We have previously explained that the really interesting concept of verifying and validating our network services. Jose has presented the architecture. Manuel has presented how to provide some profs, prof packages for this validation and verification tool. Also, would like to add that this verification tool is intended to work on top of Sonata and OSM. We will be explaining right now the Sonata support. We'll start by installing the VMB. The first step is common to what I have explained before on the service platform. So it is the same Then for instantiating, we have to install the BNB. We need to follow the second step, which is on this in this guide. We are installing BNB using Ansible, so please make sure that we are following the TNC DevOps folder. Then we can also customize this file. Plus, bear in mind that you will need to replace the platform from this file from a service platform to BNB, so the Ansible script is properly run, and then we need to run the Ansible script. To verify the installation, the procedure is the same as in the service platform. So the availability is on the and also login and password are the same. So in order to operate with the BNB, we have an instruction guide which are available here. This guide, we will need to first connect our BNB to the SONATA service platform. That's something that we do it by the platform settings. We integrate this with the SONATA service platform. Then once we have connected the SONATA service platform to our BNB, we need to update to upload the packages. The first package is the network service package that we usually explain, and the new package is the test package that we have also generated with the props. This is a ping only, so we make sure that the service is deployed. We install them using the TNC CLI tool into our service platform, and then we are, if they are uploaded correctly, they appear in our packages. So you see here the different packages that are available on our BNB. So then we need to execute the test. It can be triggered, a test can be triggered if the tags on the NSD and TD on the test descriptor match, so the testing tag is present both in the package description in the package descriptor. In case that the test can be run using this green button on the right side of the tests, so the test can be triggered. If you can accept to automatically run the test. So when you trigger the green button, a new window appears, so we'll to run automatically the test. That's useful for having all the results automatically. Then once a test runs, the status can be observed at BNB test plans. Test plans are generated and are scheduled. So you can see that, for example, in this case, the first test is starting and the other two tests are scheduled. Once we have test plan status is completed, all the results for that test plan can be observed. Here you obtain the different results. You see that the test plan has succeeded and the results are passed. Here you can observe later on all the different details for each test plan executed. So this is how to use the BNB. You have seen the references for the installation and operations guide, and also the different tutorials and examples that we have, so you can jump in to using this platform. As a final remarks for this webinar, just explain that if you need more help, we have some troubleshooting, we have some explanations of how to typical frequently asked questions. So when someone asks a question, we include it here in the troubleshooting. We also have a mailing list that's available for all the people using SONATA service platform, SDK, and BNB. So please reach us on the mailing list in case that you need some help. And also you can also open the GitHub issues. So you have seen that SONATA has 30 components. So each component can have some issues. If you detect the issues per component, you can directly write us a GitHub issue report. If not, you write us to the mailing list and we check which is the component which is failing, and we try to fix it. Last slide from my side is in case that you want to contribute, we also are open to new contributions. The first thing that you need to do for contributing to Sonata component, you need to fork the repository, then commit your new code on your fork. You can see, for example, myself, my fork of the TNC BNB planner component. And then once I have written my code in my repository and have validated it, I can also create a new pull request. So the responsible for the Sonata component will be the one which will be checking the pull request and accepting it and merging it with the Sonata dev branch. That's how we work at Sonata. I hope that you have enjoyed this webinar. This finishes my webinar, and we are open for a couple of questions in case of any. So you are more than welcome to ask us that. If you have more questions or more with details and so, don't worry. You send us a mail to the mailing list that I have shown you, and I will answer as soon as possible. Of course, we will distribute this webinar recording in YouTube in the coming days, and we will also be distributing the slides that we have presented today. So thank you all for all your efforts. So if there is any question, burning question, or if not, we consider this closed. Thank you very much for all your attention, and we keep in touch. Thanks a lot. This concludes the webinar. Thank you very much.